So today we're going to be talking about different types of data displays. The first type we'll talk about is a frequency table. So your frequency table has 3 columns. The first column will have the possible answers. The frequency table that's displayed here was what type of pet do you have. The second column you'll be using when you ask your questions. You'll tally what the responses were. And once you get all 50 people for your sample, in the frequency, you'll write how many tallies there were in a number. It's easier to plot on a graph and refer to instead of recounting all your tallies. The dot plot we're not going to spend any time on. This is another way to display your data, but it's not needed for your project or presentation. The histogram is needed. You must have one histogram on your paper report and on your presentation. Here, the question was score class intervals. So everyone who got a D from 60 to 70, a C 70 to 80, a B 80 to 90, and an A 90 to 100. So here only 3 people got D's, so the bar is filled and colored in until 3. 8 people got C's, so the bar is filled up until 8, and so forth. Each bar must be a different color on your presentation and on your paper report. Finally, we'll learn about the box and whisker plot. Your minimum will be at the end of the first whisker and connect to your 3 quartiles, quartile 1, 2, and 3 that make up the box. And then your maximum will be the end of the second whisker. We'll also talk about how to find the IQR and what that means, and how to find any outliers. So let's get started. The median, or the middle number, is the same as Q2. Same exact thing. Q2, middle number, median, it's all the same. When we do our box and whisker plot, we usually get the numbers from a discrete data. So whether that data is the weather every day, or it's how many M&Ms you ate for a week, it's not labeled, and it's not graphed. It just looks like a list of numbers. The data we have today is 10, 15, 20, 4, 16, 17, 6, 18, 20, 14, and 17. So the first thing we're going to do is we're going to look at all these numbers and put them in ascending order. So it's going to be 4, 6, 10, 14, 15, 16, 17 twice, 18, and 20 twice. 2, 3, 4, 5, 6, 7, 8, 9. Yep, got all my numbers. Now, the first thing we're going to do is find the middle number, the median, the quartile 2. All the same thing, that middle number. So because I have 11 data entries, I'm going to do this using math because we are in Algebra 2. And I'm going to say 11 plus 1 divided by 2 will be 12 over 2. And that gives me 6. So the position of my quartile 2, also known as my median, will be the 6th number in the data list. So I'll go 1, 2, 3, 4, 5, 6. 16 is my quartile 2. Now this data has been cut in half here at 16, so I'm going to take these 5 and find my lower quartile or my quartile 1, and then these 5 will be my upper quartile or quartile 3. So because I have 5 numbers on this side and 5 numbers on this side, my quartile 1 and quartile 3 position will have the same math. Your quartile 1 and quartile 3 should be in the same position for each new set of numbers. So there's 5 numbers on this side, 5 numbers on the other. So I'm going to say 5 plus 1 divided by 2 will give me 6 over 2, which gives me 3. So I know it will be the 3rd number in each set. Here, for quartile 1, I count 1, 2, 3, and my quartile 1 will be 10. For my quartile 3, my 3rd number is 18. So my quartile 3 is 18. My minimum is very straightforward. It's the smallest number in my data set, which is here is 4. My maximum is the largest one, which is 20. And to find my range, I'll take my maximum and subtract my minimum. So here my maximum is 20, my minimum is 4, and that gives me a range of 16. Now when I talk about my interquartile range, or the IQR, the same one we saw in that chart here, I'm going to take my quartile 3 and subtract my quartile 1 and get my interquartile range. Here my quartile 3 is 18, my quartile 1 is 10, so my interquartile range is 8. Now I'm going to add one more that you should know because you'll need it when you graph, and that's your outliers. Your outliers, we have a formula to find an upper outlier and a lower outlier. To find a lower outlier, we will take Q1 and subtract 1.5 times our IQR. Again, our quartile 1 or Q1 is 10. So we'll subtract 1.5 times our IQR, which is 8. And we'll end up with 10 minus 12 equals -2. Now, our smallest number is 4. So we would only have an outlier if we had a number that was below -2. Thankfully, we don't have any outliers. We actually don't want any outliers. So now we go to the upper outlier. And that formula is Q3 plus 1.5 times our IQR. Our quartile 3 was 18 plus 1.5 times 8, so I end up with 18 plus 12, which is 30. Again, 20 is less than 30, so 20 cannot be an outlier. If we had a number greater than 30, that would be our outlier. Thankfully, we don't have any outliers either way. We don't want outliers, so this is a good set of data that is represented equally. As an example, we're going to do the first problem in your homework. So it's asking to create a box plot and clearly state the minimum, maximum, Q1 through 3. And the first step that we do is to put our data set in ascending order. So we're going to do 7, 8, 9, 10, 11, 12, 18. So the first thing we're going to do is find our median, our middle number, our quartile 2. So our quartile 2, or the middle number, we find with math again. So we have 6 data entries. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. What did I do wrong? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Ah, that's it. I added an extra number. There is no 8 in my data set. Knew that looked wrong. There. So I have 2, 4, 6, 6 numbers. So I'm going to say 6 plus 1 over 2 gives me 7 over 2, or 3.5. So I know that the position of my quartile 2 will be at 3.5. So I come back and I count 1, 2, 3, 4. So I know my quartile 2 will be between 10 and 11. Because it's only a difference of 1, I know that smack dab in the middle will be 10.5. It's going to lie right there. If you have a greater difference between the two numbers, you can always add them together and divide by 2 and find the average of those two numbers. It works here as well. So I can say 10 plus 11 over 2 will give me 21 over 2, which will still give me 10.5. Now that the data set is before I move on, because I have my quartile 2, I'm going to draw a line right above where that 10.5 belongs. Then my data set is divided in half, so I'll have 3 on this side, 3 on that side. I don't really have to do math here because with my eyes I can see that my middle number is the second one, so 9. So 9 is going to be my quartile 1. I'm going to draw a line right where it belongs. And then 12, that's a positive 12, is where my quartile 3 belongs. And I'm going to connect my quartile 3 and quartile 1 to make a box with quartile 2 in the middle. Sometimes it won't be exactly in the middle, it'll be a little off center, and that's okay because that's still the location of our quartile 2. Then we're going to find our interquartile range. So remember that IQR equals Q3 minus Q1. So I'm going to subtract 12 minus 9 equals 3. And now I'm going to see if I have any outliers. So to find that lower outlier, I'm going to take my Q1, which is 9, and I'm going to subtract 1.5 times 3. So I have 9 minus 4.5 equals 4.5. My lowest number is 7. It's not below 4.5. So I can plot my minimum and attach it to the box with a whisker. Now I'm going to look for any outliers above, my upper outliers. So now I have 12 plus 1.5 times 3, or 12 plus 4.5, which gives me 16.5. 18 is greater than that. So 18 will be my outlier. All I do is draw my dot where 18 should be, and I look at my next, I look at the next highest number, which is 12. 12 happens to be my Q3. So I can't create a whisker here. If there was a third number in between 12 and 18, like 15, I could put a dot here and connect it with a whisker. But since I don't have another number listed between 12 and 18, my maximum will be my outlier, and